Okay, hello everyone. So it is time for our second lecture for chapter 1, section 2. It is about solutions for differential equations and initial value problems. So let me start by a definition or explicit solution. So explicit solution for a differential equation. Now, what is an explicit solution? Explicit solution, suppose that, let's say here, y is our dependent variable. Yeah, and x is our independent variable. Now, if we have a differential equation, so here, if you have a differential equation, this means you're going to have dy over dx equal something, right? Now, you will undo the derivative, so this is the differential equation. Now, when you undo the derivative, what you will have? You will have maybe y equal to, say, a function of x. So, function of x. Yeah? This formula, y equal f of x, is called explicit formula. So, explicit formula. And we call it explicit, so explicit because y is written explicitly in terms of f. And this we will call it, so it will be an explicit solution. If and only if you go and replacing y with f of x, y prime with f prime of x, and so on. All the derivatives are replaced by the derivatives for f. Then you get that the differential equation holds, or the differential equation is correct. So when you replace in the differential equation, then the differential equation holds or gives an identity. Identity means left hand side equal right hand side. Yeah. So why I'm calling this explicit solution? Is there anything else called implicit solution? So let me go. Still we have dependent variable, we have independent variable, but now I will call the solution in a different way. Suppose that while solving, or let me go with implicit solution now. Let me change the color. Implicit solution. In this case, you will have something like, I don't know, the book is calling that phi of x and y equal constant. C is a constant. So this is a function of x and y, so equal c. So y here is not an explicit. So this is an implicit equation. Implicit equation, which means y is not written as a function of x. So, but of course, sometimes you may be able to change this to explicit. So let me just first focus on implicit. So this is implicit equation. Y and x, so expression in y and x equal a constant. I'm going to tell you what is the story of this constant later. So implicit equation. Now this phi will be is a solution for a differential equation if and only if, replacing, how are we going to write? If and only if you change, okay, so it is a solution if it is, okay, it is satisfying the differential equation. But how are we going to write this? We're going to write if it contains one or more explicit solutions. So if it contains, or if phi contain one or more explicit solutions. Yeah. Now this is not clear. So how you gonna check? How you will check for implicit solution whether it is satisfying the differential equation or not? So to check, how to check if it is a solution or not. So I'm gonna say there's two methods. Number one, so you could first do change. So step one, I'm gonna say go like the following. Step one, change explicit solution to implicit, implicit solution to explicit solution, if possible. If not possible, I will give you an alternate method to do that. Now let me just, this is step one. Step two, replace, differentiate and replace the first derivative with its value. So step two, differentiate and change y with its value, dy over dx by its value, and so on. Yeah, and so on. Yeah. Now step 3, plug. So this is plugging in the equation. So in the differential equation, Now if right hand side, left hand side, okay, left hand side of differential equation still equal right hand side, then it is a solution. Then the implicit formula, then the implicit then phi, then phi xy equals c is a solution for the differential equation. Let me show you one explicit solution and one implicit solution for a differential equation. or maybe we go and solve some problems from the book. Maybe it is better. So before solving anything, now I want just to give you a remark. Note that if we have first order differential equation, yeah, then when you if you do solving, then how you do solving? Then you do integration. So you need to integrate, or which is equivalent to integrating one time. Then you will get one constant of integration. One constant of integration. Yeah? So if you have a first order, then when you go, so this means that general solution, so the general solution for first order differential equation or ordinary differential equation will have a c in it, yeah? Will have one c, so one constant of integration. So this is the constant of integration. Note that from now on I will start calling general solution GS. So the general solution for first order, so you have one derivative, right? One derivative. Then to find y, you need to integrate only one time. Let me just show you. Suppose that you have dy over dx equal to, say, x. Now you want to solve, so find y. So solving. How you solve? Then it is easy. So say you want to integrate both sides, yeah, with respect to dx, right? Now dx with dx is cancelled, and then you're gonna have y equal to, now you're gonna use the power rule, x squared over 2 plus c. This is a c. Now this thing here is the general solution for the black one. So here, this is the general solution for dy over dx equal to x. Note that you're going to have one constant of integration. So what's going to happen now if you have second order, yeah? Second order differential equation. Second order differential equation. Then solving, then you have here second derivative. So you're going to have d squared y over dx squared. Or you could, I can give you something like this, d squared. So let's make the independent variable t squared. So this is acceleration, right? So if you go for applications, so the second derivative of the distance is the acceleration. So y is the distance. So you're going to have acceleration. Integrate, so solving, integrate one time, we will get velocity. So I'm going to have second derivative of y with respect to t squared. Then integrate one time. Then you're going to have dy over dt equal something plus constant number 1, right? Because you integrated one time, so first constant of integration. So here you get what? Here you will get velocity. And when you integrate for a second time, so if I integrate for a second time to get the distance, so note that when you are solving, then you need y, right? So y, what is y? Now when you integrate, then you get a so you get something, and here you get c1t plus c2. Now you get a second constant of integration. So if you have second order, you get two constants of integration. Let me write this. Second order differential equation implies two constants of integration in the general solution. So this means two constants in the general solution, and so on. If you have, so C1 and C2, if you have third order differential equation, ordinary differential equation, then in this case you're going to have three constants of integration, and so on, and so on. Yeah? Now, to find these constants, usually in physics, so I give you, for example, here, so I give you acceleration. Let me just remind you with something. So let me just say I'm giving you acceleration. Then, so to find constants, the value for these constants, the value. So this is kind of remark number two. Remark number two, to find the value for these constants, you need initial values. Yeah, initial values. So you need initial values. I'm gonna write it like this: initial values, or initial value. Now, for example, if I give you a first order dy over dx equals, say, 2xy, and I give you something like y of 0 equal 1, this, and I say solve, this is in the future. In the future, I'm going to tell you solve, then this going to give you a y, and y going to contain one constant of integration, and to find this constant of integration, then you need to use the initial condition to find that c. So solve, then you get solution, general solution with constant of integration. Yeah, and then this thing is to find C, use this initial condition. So this is called initial condition. Let me write it: initial condition. I'm gonna write initial condition like this: initial condition. Yeah. And if I'm giving you a second order, of course I'm gonna give you two initial conditions. I give you acceleration, and I ask for the distance, then I have to give you initial distance and initial velocity. Yeah? So let me just tell you one thing. When I give you this thing alone, this is alone called differential equation. And it is ordinary differential equation, right? And if you go for this thing, this is initial condition. So this thing is initial condition. Initial condition. Now together, so together, these together, called initial value problem. And we write it as initial value problem. Initial value problem means ordinary differential equation plus initial condition. Now let me give you some examples just to explain all these ideas, how to check whether something given to you is a solution for the differential equation or not, and how to find the constants if I give you initial values. I'm taking a question from the book. There's a remark before doing this remark. Just I want to just remind you with one more thing. If you cannot find explicit solution, then so if you cannot find explicit solution, then to proceed with derivatives, then you can implicit solution, you can differentiate directly, because it is called implicit solution for sure. This remind me with implicit differentiation. Yeah. So I give you the procedure how to proceed with checking the solution, whether it is a solution for differential equation or not. If you have explicit solution, then you can proceed. If it is implicit, change it to explicit. What if I cannot change to explicit? Then I can do implicit differentiation. So implicit solution means you may do implicit differentiation. Now let me show you one or two questions from the book. Here is a question from the book. Which question is this? Question 26, page 35. It says, show that xy cube minus xy cube sine x equal 1 is an implicit solution for or 2. This differential equation dy over dx equal to x cosine x plus sine x minus 1 times y over 3x minus x sine x. Good. So let me just proceed in the following way. Here is the solution. So solution, how you want to check. So this is something that you need to check. So this is kind of, you have phi here. So let me write here. So this thing is a function of x and y equal, this thing is a c, right? Function expression of x and y equal a constant. Now you need to check that it is satisfying this equation. How are you going to do this? You have two ways to proceed with this. Can you solve explicitly? Can you solve for y? Now I have implicit, right? Implicit formula for candidate solution, right? Yeah. Now what is that formula? It is the following formula: y cubed minus xy cubed sine x equal 1, right? Now let me try to change it to explicit. So on my steps here, I'm trying to change to explicit. First, I take y cubed as a common factor. So here I lift up, so let me just make it here. So I'm taking y cubed outside, and here is x minus x sine x. So I'm taking y cubed as a common factor here, y cubed out. So equal 1. Now I'm solving for y to get explicit, right? So I'm trying to find explicit solution. Now I'm going to next do dividing. So dividing here, I'm dividing over x minus x sine x. And then you're going to have y cubed equal to 1 over x minus x sine x. Good? Yeah? And now I need y. Y is this thing power 1 over 3. So you're going to have 1 over x minus x sine x. Third root, right? Third root. So third root of that. Yeah? And then this thing is the same as, if you like, you're going to have x minus x sine x. I can change to power. It is power minus 1 over 3, right? So this is power 1 over 3. So it is power 1 over 3 here, power 1 over 3 here. And then you can do it up and make it x minus x sine x power minus 1 over 3. Now, what are these steps? Now, what did you do here? What did you do here? Changing, so explicit, implicit to explicit. Why you did that? I did that to explicit, right? I did that to avoid implicit differentiation. So I'm trying to avoid implicit differentiation. So now the next step will be just find the derivative dy over dx. So we are here up to here. So we need only that thing, right? So we have y. This is y. So I have that one. Yeah, I have that one. And now I need dy over dx, and I need to check that it is equal that thing. So dy over dx, this is a solution, the solution. Continue with the solution, dy over dx. I can use the chain rule, it is minus 1 over 3. And then times x minus x power sine x power minus 1 over 3 times the derivative of the inner. So I'm using chain rule here. Times the derivative of that inner. So what is the derivative of that inner? So you're going to have 1 minus, so derivative of x is 1 minus, I'm going to here write, what is the derivative of this? You need product rule. The product rule is 1 times sine x, yeah, and then plus x cosine x, yeah, and then here is the bracket, yeah. Now let me try to compare this with that one, right? Sorry, this is power minus 1 over 3 minus 1, right? Now this minus 1, I like to have it down because I can write this, okay. So this minus, I will multiply it here. So let me go with that minus and multiply it here and there, yeah? And then I'm going to have the following. So I'm going to have the following. It is kind of, you're going to have x minus x sine x. And I like to keep the minus 1 over 3 here, right? And I like to keep x minus x sine x power minus 1. Note that minus 1 and minus 3, these are this thing, right? So this thing, yeah? So the last thing is multiplying that minus. So, well, what you're going to have for that thing, you're going to have minus 1 plus. Now, no need for the bracket anymore because now this is a plus. And you're going to have sine x plus x cosine x. Yeah? Now, this thing, this thing here, it can go down, down. And I think I forgot also here the 1 over 3. So we have the 3 is already down and this is down, then I'm going to have the following. So I'm going to have x minus x sine x, yeah? And then that one, which is minus 1 plus sine x plus x cosine x, yeah? And the rest, minus 1 over 3, and over 3 and x minus x sine x. Good? Now note that thing is y, right? If you go to the formula that was here, that thing is y, right? This is y. Yeah, it was written there, it was y, right? Now comparing, so you're going to have x cosine x, sine x, minus 1, and that one is y, yeah, multiplied with y. And then here you're going to have 3 and x minus x sine x. So it is really true. So differential equation, so that y, which is dy over dx, so that y, which is, I can write, what was that? X minus x sine x power 1 over 3 minus, it is really a solution, is a solution. Yes, it is a solution. This is one method in which I didn't use implicit differentiation. I'm going to show you another way. So we are done with this, but I can show you another way to do this. Another way. So the second way, it says, hey, you have implicit formula, so why you don't use implicit differentiation? So here's solution using implicit differentiation. So let me just go with that thing which I like from before. I like to have it like this, x minus x sine x. So the first step was to take y cubed as a common factor, and then you have that one. Now the first step is to go and say I want differentiate with respect to x. Good? Now here you go with product rule. Product rule, and in fact even here rule, even here you need a product rule. But here product rule with implicit differentiation. Yeah? Now why implicit? Because y is a function of x and you need to multiply by the derivative of y when you differentiate y. Now when you differentiate this with respect to x, then you say 3 y power 3 minus 1, and now you multiply with the derivative of this with respect to x times y prime, so this is the derivative of this, and you leave the second one, which is x minus x sine x, yeah? And then now this is the derivative of the first, leave the second, and then plus, you leave the first and differentiate the second. The second one, the derivative, I did that before, it was 1 minus, now here you get sine x, yeah? And then the second one you get plus x cosine x, yeah? And then this thing should equal the derivative of the number 1. You get 0, right? Yeah? You get 0. Now, what is next? So you have 3 y squared, y prime, and here you have that thing which is, okay. So what are we trying to do? We need to solve for y prime, right? And compare with this. So this is the derivative of, if you like, I can replace this with dy over dx, right? Just to be able to compare. Now what is dy over dx? Solve for dy over dx, what you will have? You will have dy over dx equal, now this you take it to the other side, then you get minus, so minus minus, you know, now if you take this minus, so minus this, okay, let me write it two steps, minus 3, and then you have 1 minus sine x plus x cosine x, yeah, and this is divided by that thing which is 3y squared, yeah, and then here we have x minus x sine x. Good, we are almost there, right? Now the only thing is just to take this minus, multiply it here and there, yeah, and try also to simplify this with that, right? So here this cancel with that and you get just 1y, right? Now let me go and rewrite things now. So what did we get till now? So we got the following. So we got that dy over dx, dy over, so I'm continuing here, dy over dx equal to, now this minus goes here, so you get y times minus 1, and here you get plus, no need for that bracket now, it is sine x plus x cosine x, yeah, and then divided by 3 and x minus x sine x. Is it the same one? It is the same one, so we are done, yeah. I will give another question just to check explicit solution now. I don't remember the question number here. Oh, okay, we have it here. So question 22, page 36. It says verify that the function phi of x equals c1e power x, yeah, and then plus c2e power minus 2x is a solution to the differential equation, the linear differential equation, this one, d square y over dx square plus dy over dx minus 2y equals 0 for any c1 and c2 constants, yeah, and then this is the A part, and then the B part, it says determine C1 and C2 so that the initial conditions y0 of y of 0 is 2, comma y prime of 0 is 1 is satisfied. Okay, very good. So here, let me just show you the difference here. Look, you have here, is that explicit or implicit, and where is y? I don't see y. So when you go for a solution, so you look for dependent variable. So a solution is dependent variable equal function of the independent variable. So this is y equal, yeah, because you look for y. So this is the dependent variable. So you look for the dependent variable, not for the independent variable. So you look for y, then y is that function of x. Is this y good to be a solution for this? Let me check. So let me check if this is really a solution. Solution for this. For A, so you have y, right? You have y, which is c1 plus c2 e power minus 2x, right? Now this is my y. Now I can replace y here in the differential equation. So here is the differential equation, right? In the differential equation, you replace, I know what to put for y, yeah? You know what to put for y. So this is y. Now what should I put for dy over dx? Then I need dy over dx, yeah? dy over dx is the derivative of this with respect to x. Then this is a constant, and the derivative of ex is ex, and the derivative of this, by chain rule, you get minus 2 c2 e minus 2x. Now I know what to put for this guy here. Now the third thing, I don't know what to put for the second derivative. Then I need the second derivative. D square y over dx square equal to differentiate again, right? Then you get c1 ex, and here you get plus 4 c2 e minus 2x, right? And this thing is the second derivative, right? Second derivative. So this thing goes here, yeah? It goes here, yeah? And now, after I put all these things, I need to add and subtract double of that, and if I get 0, then I'm done. It is a solution. Let me keep this for a moment. So let's go and check second derivative. So second derivative is c1. So I'm writing this now. I'm writing this. c1 ex plus 4 c2 e minus 2x. Now I'm writing now this thing. Yeah, this thing is here. Yeah. Is it plus? Yes, it is plus. Now, what is the first derivative? It is c1 and ex minus 2 c2 e minus 2x. Yeah? And then I'm writing now minus 2, and now I'm writing y here, right? What is y? It is here, you need to put a bracket because this minus 2 is multiplied with the whole y, okay? Then c1 ex plus c2 e minus 2x. Now I'm trying to check, is this, so question marks, is this 0? Now if you go now and check things, you get here c1 ex, and here another c1 ex, and here, so you get 2 of them, and here minus 2, so you need to multiply this, right? So you need to multiply this here and there. So are we getting here minus 2ex? Yeah, so this thing and that thing will cancel, right? And now again, if you go with the other one here, you have 4c2 and you have minus 2c2, and you have another minus 2c2, so 4 minus 2, then really you are getting another 0. So this guy here, this guy goes with this and that, right? Then you get 0 equals 0, then yes, it is a solution. Yeah. Now one more thing, it says, yeah, you showed me that it is a solution, but I need from you to find me C1 and C2. Provided that I'm giving you what? I'm giving you some initial values. Imagine that you are looking for distance, and for the distance I give you acceleration, and when you integrate acceleration you get two constants of integration integrations. Then I need to give you like initial distance, and I'm giving you here something like initial velocity to find C1 and C2. So here's what we have. So solution for B, so I'm done with that thing. So let me go with this part now. Solution for this part. We know that this thing, which is y equals C1 EX minus or plus C2 E minus 2X, this is called general solution. General solution, yeah? Now, it has two constants, and you need to find these two constants. Now, if you go with y of 0 equal to, what does this mean? This means that x is 0. When x is 0, this implies that y is 2. Yeah? Now you plug x equals 0 and you plug y equal 2. Yeah? Then if you plug x equals 0, then if you plug this x equals 0, then you get C1 e power 0 plus C2 e power 0 also, because minus 2 times 0 is 0, and equal 2. Then I'm getting here an equation says C1 plus C2 equal 2. You know that this thing is 1 and this thing is 1. Yeah? This is, I will call it equation number 1. And also if you go for the second condition, which says y prime of 0 is 1. This means when x is 0, then y prime should be 1. But this means that replace x with 0, you get information about y prime. But I don't have y prime, I need to find y prime first. So first find y prime. Let me show you how to proceed with this. So let me show you. So here is what you need. First you need dy over dx, and we know how to differentiate. You get this, and minus 2 c2 e minus 2x, right? Now you know that this thing I can call it y prime, and here it says plug x equals 0, then you get C1 E0 minus 2 C2 E0 equal, what is y prime? It will be 1, right? And from this, with rearrangement, so this guy will be 1, and this guy will be 1, and then you get C1 minus 2 C2 equal 1. Good? So this is equation number 2. So this is equation number 2. And this is equation number 1, right? Now you need to solve for C1 and C2. So you have C1 plus C2 equal 2, and you have C1 minus 2 C2 equal 1. Suppose that you want to use elimination method. So let's multiply. So equation number 1 multiplied by 2, what you will get? You will get 2C1, 2C2, 4. 2C1, 2C2 equal 4. And then equation number 2 as it is. Equation number 2 is C1 minus 2C2 equal 1, right? Now you add this. Now when you add, you get 3C1, 0. This is 0. Let's cancel with that, yeah? You make them the same but with different sign, and equal to 5. and then when you solve for C1, you will get 5 over 3. Now take this 5 over 3 for C1 and plug it anywhere. Plug it here. Yeah? Plug it here. And then solve for C2. Plug in 1. Then solve for C2, right? Solve for C2. Then this is what you're gonna get. This is what you're gonna get. So you're gonna get something like C2 will be just 2 minus 5 over 3. It will be just 6 over 3 minus 5 over 3. You get 1 over 3, right? So C2 is 1 over 3. Yeah. Then we got C1 and C2. Just I want to show you, so we are done, but just to show you what is the difference between general solution and this thing, which is I'm gonna call it particular solution. So here what we got, y equal to C1 is 5 over 3 now, and Ex and plus 1 over 3 E minus 2x. This thing is called particular solution. So particular solution. So if you have C1 and C2, then you call it general solution. If you don't have constants, then you call it particular solution. Or this solution is called solution for the initial value problem. Yeah. What is the initial value problem? The differential equation in the question plus the initial conditions, the value of y at 0 and the value of the derivative at 0 together with the differential equation, they have this solution. But the differential equation alone has the solution with C1 and C2. By this we reach the end of today's lecture. Thank you for attending, and I wish you the best, and we'll see you next time with a new subject or a new technique, or with to study techniques for solving ordinary differential equations. Thank you very much.